In this question, a statistically determinate beam is given to us, and the reactions at the supports B and C, and also the internal forces at point D in the middle of the BC part are required. We're going to start solving this question by writing the equations of equilibrium for the whole beam and determining the reaction forces. And then having the reaction forces, we can determine the internal forces at point D. So at point D, we have By. At point C, we have Cy and Cx. We can convert this distributed load to 2-point loads. We can write this is 2, this is 1. We can write this is equal to a rectangular load. This is 1 plus a triangular load, and this is 1. And then we can convert each of these loads to 1-point load. So this will be 1 multiplied by this distance, which is 2.4. So this will be 2.4 kilonewton. This will be 1 multiplied by 2.4 divided by 2. And this distance, so this will be 2.4 multiplied by 1 divided by 2, which is equal to 1.2 kilonewton. And this distance would be 2.4 divided by 3, which is 0.8. So here we have 2.4, and here we have 1.2. This distance is 0.8. Now for the x direction, the only force that we have is Cx. There's no other forces in x direction. So sigma fx is equal to 0. It means Cx plus 0, because we have no other forces in x direction, is equal to 0. So Cx is equal to 0. In y direction, we have this force, we have this force, we have this force, and we have these two support reactions. So we can write By plus Cy minus 1 minus 2.4 minus 1.2 is equal to 0. So By plus Cy is equal to 4.6. And now if we take the moments around point C, we can write sigma mc is equal to 0 in this direction. So 1, which is this force, multiplied by this distance, which is 4 meters, plus 2.4 multiplied by this distance, which is 1.2, plus 1.2 multiplied by this distance, which is 0.8, minus By multiplied by this whole distance, which is 2.4, is equal to 0. So 4 plus 2.88 plus 0.96 is equal to 2.4 By, and this will give us By equal to 3.27 kilonewton. Now if we put By in this equation, 3.27 plus Cy equal to 4.6. So Cy will be equal to 1.33 kilonewton. And now we can clean this diagram a little bit. So this is 3.27, this is 0, this is 1.33. And now in part B of the question, it's asking for the internal forces at this point. So we can cut the beam from here and take out this part. So we will have 1.33. This is 2. And we still don't know what's this value. We have a dy, we have a md, and we have a dx. And if we write the equations of equilibrium for this section, we can determine the value of these unknown forces. So we can again convert this distributed load to a rectangular and triangular distributed load, and then convert each of those distributed loads to point loads. So this was 2. We know this was 1. And we know this is 1.2, this is 1.2. And since this is changing linearly, in the middle of the load, this value would be 1.5, which is the average of 1 and 2. This is 1.2 meter, this is 2, this is 1.5. So we can write this is equal to 1.5 plus this is 0, this is 0.5, and then we can convert these loads to 2 point loads. So this will be 1.5 multiplied by 1.2, which is 1.8, and this will be 0.5 multiplied by 1.2, which is, and then divided by 2 because this is triangular. This will be 0.3, and this distance would be 1.2 divided by 3, which is 0.4. So this is 1.33 at point C. This is 0.3 at a distance of 0.4. And this is 1.8, and this distance is 0.6. This whole length is 1.2 meter. This is dy, this is md, and this is dx. So for the x direction, the only force we have is dx. So minus dx plus 0 is equal to 0. So dx is equal to 0. For the y direction, we have dy plus 1.33 minus 1.8 minus 0.3 is equal to 0. So dy would be equal to 0.77 kilonewton. And if we write sigma m at point D, is equal to 0. So 1.8 multiplied by 0.6, which is this distance, plus 0.3 multiplied by this distance, which is 0.8, minus 1.33 multiplied by this distance, and then we have MD plus MD is equal to 0. So MD plus 0.28 is equal to 0, and MD would be equal to minus 0.28, which means that MD is actually in this direction, not in this direction. So we can write MD is equal to 0.28 in this direction, and the unit is kilonewton meter. That's it. We determined the reactions at the supports and the internal forces at point D. Please subscribe to our channel if you haven't, and if you like the video, press the like button. Thanks, and see you in the next video.